So let us see the problem on decoding of linear block code. So in such problems they give you either generator matrix or the parity check matrix. So here in this problem they have given you the generator matrix and also given you the received code word, and you have to check whether this received code word is in error or not. If it is in error, then you have to correct it. And one thing is that you will get the problems with 1 bit error only. So this is the 7,4 linear block code. So we have seen in the cyclic code that I told you that you have to remember these equations. So generator matrix is in IKP k into n. So you have to remember like this. So if you remember this, there is no need to remember other dimensions of the matrix. And H is in the form Pt I n minus k into n. So you have to remember this these dimensions only, and this is also useful for the cyclic codes. So here you can observe that generator matrix IK, k is 4. So here you can see that IK, that is 4 by 4 identity matrix is there, and then this is your P, parity matrix. So it is in standard form. K is 4 and n is 7. So you have to first, in decoding you need H matrix, that is parity check matrix. So you have to obtain H. So H is in is Pt I n minus k n minus k. Pt means transpose of P. So this is P. From this P starts because starting is IK. So you have to trace where is IK. IK is this one. That means identity matrix of dimension 4 by 4, because k is equal to 4. And then this is P. So Pt is, you have to take this column as first row, so 1 0 1 1. This as second row, 1 1 triple 1 0, and this as third row, 0 triple 1. And after that you can see here, after that you have to append identity matrix of dimension n minus k. N is 7 and k is 4, that is 3. So 3 by 3. So this is the formation for parity matrix. Parity check matrix. Parity matrix is this one, P. So this is parity check matrix. So it has dimension n minus k into n. So 3 into 7. This you should remember for both the chapters, cyclic as well as linear block code. After that, in decoding part you need HT. So HT is, you have to take this transpose of this matrix. So HT is, so 1 1 0, write it as row, 0 1 1 second row, triple 1, then 1 0 1, then 1 0 0 0 1 0 0 0 1. So this is the third step. After that you have to check whether the received code word is in error or not. So the received code word is 0 1 0 1 0 1 1. So you have to find the, for that you have to find the syndrome. So how you are going to find the syndrome? You have to multiply received code word with HT. So this is your HT that we have found just now. This is your HT and this is your received code word, this one. So you have to do the multiplication. So here multiplication trick is there, so you listen carefully because it is useful in both the chapters, cyclic as well as LBC. So what you have to do? So you have to first point or note where are the ones in R. So here is the one. So this one corresponds to second row of the HT matrix. Then this one corresponds to fourth row of the HT matrix, and this one corresponds to sixth row of the HT matrix, and this one corresponds to 7th row of the HT matrix. So if you don't see for the rows also, you have to start from this side and this side, this one and this one. So here is at this position one is there, so this row. After that no one is there, after that one is there, so skip this one is there. So likewise you have to go like the in this direction and downwards in HT. So once you pointed out the ones in the R and also considered the rows of HT, after that this has no role. This R has no role. R has only role in pointing out the rows of HT. So this is the trick for doing the multiplication of the matrices. Otherwise if you do the multiplication, you have to take this one, then multiply with this column, then this row, this column, then this row and this column. This will take time. So this is the simple way to do the multiplication. So where we were, so we have noted down the ones in R, and accordingly we have marked the rows of HT. After that this has no role. Then you have to take these marked rows like this 0 1 1, then 1 0 1, then 0 1 0 and 0 0 1, and you have to do the mod 2 addition. Here also the trick is that wherever you go see odd number of ones, you have to write 1 as addition, and if there are even number of ones, you have to write 0. So here odd number of ones are there, so 1. So you have to just count the ones. So here even ones, so 0. Here also odd one, so 1. So syndrome is 101. So you have to see where is this syndrome lies in HT. So this lies here in the first, second, third and fourth row. So 101 lies in the fourth row of HT. So fourth bit from this side, from MSB, fourth bit from MSB is in error. So this is the received code word. So 0 1 0 0 1 0 1 0 1 1. So fourth bit from the so don't get confused with the side. If you take from this side, you will not get the correct answer. So fourth bit from MSB. So I am saying MSB. LSB is this one. So MSB. So 0 1 1 2 3 4. So this bit is in error because row is fourth row. So how to correct it? In binary, 1 is 0 if in error, or 0 becomes 1 if in error. So you have to just change 1 to 0. So we have changed 1 to 0 and you got the corrected code word. So this is for the LBC decoding. We will also take 2-3 again examples like this, so you will get more understanding about LBC decoding. So LBC decoding problems are asked in the university exams, and normally we miss or we do the multiplication with a conventional method. So but if you try this method for different problems in your books, when you do the study problems, and you check whether you are getting the right answer with this method, so that will save your time in your exam. So this is it for this video. In tomorrow we will see more such problems on LBC decoding, so that our LBC chapter we will cover all the, we have already covered many points in LBC. So this is the last these are the last points in linear block code chapter. So that playlist is also there on our channel, so you go through that playlist where we have covered encoder diagrams as well as how to create the tables for the linear block codes for 6,3 as well as 7,4 codes. So you can go through that playlist. In that only 2 to 3 problems we will add for the decoding, so that that playlist will be as per the university exam, it will be it would have all the points, so you can go through that playlist also.